Differentiation is the process of finding the derivative of a function. A derivative tells you how quickly a quantity is changing at a particular point. The technique of differentiation is the sum and difference rule, the product rule, and the quotient rule. The rule is, if f and g are differentiable at s, then so are f plus minus g and d over ds in bracket fx plus minus gs equals to d over ds in bracket fx plus minus d over ds in bracket gs equals to f prime x plus minus g prime x. Okay, s power of 2, it will be 2x because we differentiate it. So 2 minus 1 will be s only 2s. So minus s power of 7, it will be 7s power of 6 because 7 minus 1 will be 6. And 2 is constant, so it will be 0. So the final answer is 2s minus 7s power of 6. The rule is, if fx equal to us multiplied by vs, where us and vs are differentiable at s, then f prime x equals to us v prime x plus vs u prime x, or dy over ds equals to uv prime plus vu prime. u prime v prime, so our u is x power of 2 and our v is 3x power of 2 plus 1, and our u prime is 2x and our v prime is 6x because we differentiate it. And so based on the formula, the answer will be x power of 2 6x plus 3x power of 2 plus 1 and 2x. So we expand it will be 6x power of 3 plus 6x power of 3 plus 2x, and the final answer will be 12x power of 3 and 2 plus 2x. The rule is, if y equal to fx equal to us over vs, where us and vs are differentiable at x and vs not equal to 0, then f prime x equals to vs u prime s minus us v prime s over in bracket vs power of 2, or dy over ds equals to vu prime minus uv prime over v power of 2. So u is x power of 2 plus 3 and our v is x minus 1. So our u prime is 2x and v prime is 1. So based on the formula, we will get x minus 1, 2x minus x power of 2 plus 3 and 1 over x minus 1 power of 2. So we expand it, it will become 2x power of 2 minus 2x minus x power of 2 plus 3 over x minus 1 power of 2. So the final answer, it will be x power of 2 minus 2x minus 3 over, so we open the bracket, and x minus 1 power of 2 and close the bracket. That's it.
For question 2a, we are asked to find the derivative dy over dx for the function y equal to 5x to the power of 3 cosecant 3x plus 2. Looking at the function, it consists of two distinct parts multiplied together, a polynomial term 5x to the power of 3 and a trigonometric cosecant term cosecant 3x plus 2. Therefore, we must apply the product rule. First, let's define our u as 5x to the power of 3. Differentiating this gives us du over dx equal to 15x to the power of 2. Next, let's define our v as cosecant 3x plus 2. To differentiate this, we apply the chain rule. The derivative of cosecant is negative cosecant cotangent, and multiplying it by the derivative of the inner function, which is 3, gives us dv over dx equal to negative 3 cosecant 3x plus 2 cotangent 3x plus 2. Now, we'll substitute these components back into the product rule formula. By expanding the terms, we get negative 15x to the power of 3 cosecant 3x plus 2 cotangent 3x plus 2 plus 15x to the power of 2 cosecant 3x plus 2. Finally, to present a clean answer, we can factor out the greatest common divisor, which is 15x to the power of 2 cosecant 3x plus 2. This leaves us with our final simplified answer, which is 15x to the power of 2 cosecant 3x plus 2, 1 minus x cotangent 3x plus 2. Moving on to question 2b, we have the function y equal to 4x plus 2 divided by sine to the power of 2x. First, because we are dealing with a fraction, we need to identify our numerator, which we will call u. Our u is 4x plus 2. When we take the derivative of u with respect to x, denoted as u prime, the derivative of 4x is 4, and derivative of the constant 2 is 0. So u prime equal to 4. Step 2, identify v and v prime. Next, let's look at the denominator, which we call v. Our v is sine to the power of 2x. To find this derivative v prime, we need to apply the chain rule. We bring the power of 2 to the front, lower the power of sine by 1 to get 2 sine x, and then multiply by the derivative of the inside function, which is cos x. This gives us v prime equal to 2 sine x cos x. Step 3, apply the quotient rule. Now that we have all 4 pieces, we can recall the quotient rule formula, which is dy over dx equal to v multiplied by u prime minus u multiplied by v prime over v to the power of 2. Let's substitute our values into this formula. We plug in v times u prime, giving us sine 2x multiplied by 4. Then we subtract u times v prime, which gives us 4x plus 2 multiplied by 2 sine x cos x. All of this goes over our denominator square, which is sine squared x to the power of 2. Step 4, simplify and factor out. Now, let's clean this up. In the denominator, sine squared x to the power of 2 becomes sine to the power of 4x. If you look closely at the denominator, both terms share common factors. We can look to factor out 4 sine x to make things cleaner. From the first term, factoring out 4 sine x leaves us with just sine x. For the second term, notice that 4x plus 2. 2 is equal to 2 multiplied 2x plus 1. 2, which is 4 multiplied by 2x plus 1. So factoring out that 4 and the sine x leave us with 2x plus 1 cos x. This gives us dy over dx equal to 4 sine x minus 2x plus 1 cos x divided by sine to the power of 4x. For our final step, we can simplify the fraction by cancelling out 1 sine x from both of the numerator and the denominator. The sine x on top cancels out, and the sine to the power of 4x on the bottom becomes sine to the power of 3x. This leaves us with our final answer, which is dy over dx equal to 4 sine x minus 2x plus 1 cos x divided by sine to the power of 3x.
Assalamualaikum, my name is Iman Udina and I will be solving the third question. Given y ln 3x minus exponential to the power of 2x plus 1 minus tangent 4y is equals to 0. Find dy over dx using implicit differentiation. For the first step is to differentiate both sides with respect to x. For the term y ln 3x, I use the product rule, resulting in d over dx times y ln 3x plus d over dx times ln 3x. For the term negative exponential to the power of 2x plus 1, I use the chain rule, resulting in minus exponential to the power of 2x plus 1 times d over dx times 2x plus 1. For the term negative tangent 4y, I use the chain rule too, resulting in minus secant squared 4y times d over dx times 4y. After differentiating all of those terms, I got ln 3x times dy over dx plus y times 3 over 3x minus exponential to the power of 2x plus 1 times 2 minus 4 secant squared 4y times dy dx equals to 0. After simplifying this equation, I end up with ln 3x dy over dx plus y over x minus 2 exponential to the power of 2x plus 1 minus 4 secant squared 4y dy dx. And now for the second step is to put the terms with dy over dx on one side of the equation. So you get ln 3x dy over dx minus 4 secant squared 4y dy dx equals to negative y over x plus 2 exponential to the power of 2x plus 1. And for the third step is to factor dy over dx, resulting in dy over dx times ln 3x minus 4 secant squared 4y equals to 2 exponential to the power of 2x plus 1 minus y over x. And now for the final step is to solve for dy over dx. So I get dy over dx are equals to 2 exponential to the power of 2x plus 1 minus y over x over ln 3x minus 4 secant squared 4y. And once you simplify that, you will end up with the final answer for the question, which is dy over dx are equal to 2 exponential to the power of 2x plus 1 minus y over x times ln 3x minus 4 secant squared 4y. Thank you.
Now, I will present question 4, which requires us to use linear approximation to estimate the value of the fourth root of 80.99 minus 2 divided by the square root of 80.99, correct to the 3 decimal places. First, let the function b f of x equal x to the power of 1 over 4 minus 2 x to the power of negative 1 over 2. Next, we differentiate the function using the power rule. The derivative of x to the power of 1 over 4 is 1 over 4x to the power of negative 3 over 4. The derivative of negative 2x to the power of negative 1 over 2 is positive x to the power of negative 3 over 2. Therefore, f prime of x equal 1 over 4x to the power of negative 3 over 4 plus x to the power of negative 3 over 2. Since 80.99 is very close to 81, we choose x naught equal 81 as our approximation point. Next, we calculate delta x. Delta x equal x minus x naught. Substituting the values, delta x equal 18.99 minus 81, which is equal to negative 0.01. Now, we find the value of f of x naught. Substituting 81 into the function, we obtain f of 81 equals 81 to the power of 1 over 4 minus 2 times 81 to the power of negative 1 over 2. The fourth root of 81 is 3, and 81 to the power of negative 1 over 3 is 1 over 9. Therefore, f of 81 equals 3 minus 2 over 9. This gives 25 over 9, which is approximately 2.777778. Next, we calculate f prime of 81. Substituting 81 into the derivative gives 1 over 4 multiplied by 1 over 27 plus 1 over 729. After simplifying, we obtain 0.010631. Now, we apply the linear approximation formula. F of x naught plus delta x is approximately equal to f of x naught plus f prime of x naught multiplied by delta x. Substituting all the values obtained earlier, we have 2.777778 plus 0.010631 multiplied by negative 0.01. After simplifying, we obtain 2.777671. Finally, rounding the answer to 3 decimal place gives 2.778.
In conclusion, differentiation is an important concept in calculus that helps us determine the rate of change of a function. Throughout this presentation, we discussed the meaning of differentiation, applied various differentiation techniques to solve different types of functions, used implicit differentiations, and applied linear approximation to estimate function values. These techniques are useful in solving mathematical problems accurately and efficiently. We hope this presentation has improved your understanding of differentiation and its applications in calculus. Thank you for your attention.